Hello, Accelerated Chemistry students. This is Ms. Christopher Lee, and this is your Chapter 20, Section 2 video notes all over assigning oxidation numbers. So, an oxidation number is a positive or negative number assigned to an atom to indicate its degree of oxidation or reduction. As a general rule, a bonded atom's oxidation number is the charge that it would have if the electrons in the bond were assigned to the atom of the more electronegative element. So, in binary ionic compounds, the oxidation numbers of the atom equals their ionic charge. So, for example, in NaCl, we have the sodium plus ion and the chloride ion, and the oxidation number of sodium is going to be +1, and the oxidation number of chlorine is going to be -1. Easy enough. So here's some rules for assigning oxidation numbers. So rule number 1, the oxidation number of a monatomic ion is equal to the magnitude and sign to its ionic charge. Basically, if you have an ion in your equation, then the oxidation number of that ion is the charge of the ion. So for example, if you have the bromide ion is Br-, so the oxidation number is -1. If you have the Fe3+ ion, then the oxidation number is +3. The oxidation number of hydrogen in a compound is +1, except in metal hydrides. So most of the time, if hydrogen is the first thing, it's going to be +1. And if it's the second thing, it's going to be -1. The oxidation number of oxygen is always -2, except for when it's in peroxide, then it changes to -1, and it becomes +1 if it's attached to fluorine. The oxidation number of an atom in uncombined elemental form is going to be 0. So anytime you're looking at an equation and you're looking at the elemental form of this element, it's going to have an oxidation number of 0. So for example, if you're looking at potassium metal or nitrogen gas, both of those are going to have oxidation numbers of 0s because they're in their elemental state. For a neutral compound, the sum of the oxidation numbers is that I'll say this again. In a neutral compound, the sum of your oxidation numbers is going to be 0 because your compound has an overall charge of 0. For a polyatomic ion, the sum of the oxidation numbers is going to be equal to the ionic charge of the ion. So let's do some example problems. So what is the oxidation number of each kind of atom in the following ions and compounds? So SO2, CO3 2-, Na2SO4, and NH4 2s. So we're going to have to go through each individual element in these compounds to determine their oxidation states. So we're going to use the rules to assign oxidation numbers. So let's look at the first one, SO2. Well, we know that there are 2 oxygens, and each oxygen has an oxidation number of number 2. That's from rule 3. Or excuse me, -2, which is from rule 3. And we know that the sum of the oxidation numbers between the sulfur and the oxygen needs to equal 0 because this is a neutral compound, and that's because of rule 5. And so that tells us that sulfur has to be +4 because if sulfur is a +4 and we have 2 -2s, the overall oxidation state of that formula is going to be 0. So if we look at SO2, this is how we write it. Oxygen is -2, sulfur is +4. Easy enough. Let's look at the second one. The oxidation number of each oxygen is going to be -2 in this carbonate ion. The sum of the oxidation numbers for carbon and oxygen needs to equal the ion charge, which is -2. And then the oxidation number for carbon in that case needs to be +4 because if carbon's +4 and we have 3 -2s for each oxygen, that will equal an overall charge of -2. So let's look at this. I have an overall charge of -2. Each oxygen is -2. Carbon has to be +4. All right, let's look at Na2SO4. So the oxidation number of each sodium ion is +1. The oxidation number of oxygen is -2. So the one that we don't know is sulfur. So let's do some math. The overall charge of the compound is 0. So we have 4 -2s and 2 +1s. So sulfur has to be a +6 in order for all of those charges to cancel out. So -2 +1. Make sure you write a +1 instead of +4. That's a typo. And then the overall charge for sulfur is going to be +6. Okay, and last one. Ammonium ions have an overall charge of +1. So the sum of the oxidation numbers for the hydrogen and the nitrogen need to equal +1. The oxidation number of hydrogen is going to be +1 in this case. So the oxidation number of nitrogen needs to be -3. And then since we have 2 of those with an overall 2+ charge, sulfur needs to have a -2 oxidation state. So if we look at this together, we have a -2 for the sulfur, a -3 for the nitrogen, and a +1 for hydrogen. All right, so the results are consistent with the rules for determining oxidation numbers, so that's how we know we did it correctly. And also, the addition of oxidation numbers correctly gives you the final overall charge for the ion and the 3 neutral compounds. Now, make sure that when we are doing these, and we're going to do a lot of these in class tomorrow, that you are paying attention to overall charges of the compound that you're talking about. Is it a compound that's neutral, or is it an ion that has a charge? So you could define oxidation and reduction in terms of change in oxidation number. So an increase in the oxidation number of an ion or atom indicates that it was oxidized or underwent oxidation. A decrease in the oxidation number of an atom or an ion indicates reduction. So let's look at another example problem where we're going to identify what's being oxidized and what's being reduced. So we're going to use changes in the oxidation numbers to identify which atoms are oxidized and which are reduced, and then also identify the oxidizing agent and the reducing agent. So here's our first equation and then our second equation. So let's look at these. So first, we're going to show an increase in oxidation number that will indicate that that atom was oxidized. If there's a decrease in oxidation number, that means that that ion or atom was reduced. And the substance that is oxidized is in a redox reaction is the reducing agent, and a substance that is reduced in a redox reaction is the oxidizing agent. So we're going to use rules to assign oxidation numbers to each atom in the equation. So here's our equation. So we're going to go through, do we have any elemental substances? We do. Chlorine is Cl2, that's diatomic chlorine, so that has an oxidation state of 0 because it's an element. Same thing with bromine, that also has an oxidation state of 0 because it's an element. Next, we're going to look at the ones that we know. So we know that bromine's in group 17, so its oxidation state is -1. That means hydrogen in this case is going to be +1. Chlorine is going to be a -1, and hydrogen is going to be a +1. Now we have to sit back and figure out, did anybody change oxidation states? Did anybody change their charge? Well, yes, they did. Cl went from a 0 to a -1, and Br went from a -1 to a 0. So what does that mean? So since Br minus went from Br2, the oxidation state went from a -1 to a 0. So that is our reducing agent because he was being oxidized. He lost that extra electron, which made him negative. And for reduction, we know that Cl is going from Cl2 to Cl, and our oxidation states go from 0 to -1. And why is Cl -1? Because he gained an electron, which means that he's the oxidizing agent. Let's look at example number 2. So here's our equation. First, do you have any elements in their elemental state? You do. You have carbon and oxygen, so those are both 0. Now, oxygen's always -2. And there are 2 of them. So the overall charge for that oxygen right now is -4. So that means that carbon has to be +4 in order for those to be neutral. So now let's look. Did anybody gain charge? Did anybody lose charge? Well, carbon's oxidation state went from 0 to +4. So that means that he was oxidized because he lost some electrons. And then oxygen went from 0 to a -2. And so that means that he was reduced because he gained electrons. Remember, whatever's oxidized is your reducing agent, and whatever is reduced is your oxidizing agent. So it makes sense that what is oxidized in a chemical reaction is the reducing agent because it loses electrons. It becomes the agent by which the atom that is reduced gains electrons. And conversely, it makes sense that what is reduced in the chemical equation is the oxidizing agent because it gained electrons. Okay, let's look at the final problem of the day. So can we determine the oxidation states for the chemical reaction below for everybody? And then also determine what's being oxidized or being reduced. All right, so here we go. So any elements in their elemental state. Zinc, that's a 0. All right, now let's look for anyone else that we know. Well, we're just going to go from left to right as we go through this. Oxygen we know is -2. There are 2 of those. So that means the total charge of oxygen is -4. That means that manganese needs to be +4. So that one's done. Next one, we know that chlorine is -1. In this case, hydrogen is going to be +1 and nitrogen is going to be -3. Next, chlorine's -1, zinc is +2. Next, oxygen's -2, and there are 3 of them, so that is -6. There are 2 manganese, so that means that each manganese is going to be +3. Next, hydrogen in this case is -1, and in this case, nitrogen is going to be +3. Oxygen's -2, hydrogen's +1. Okay, so now we got to look and see, did anybody change charge? So in this case, zinc is reduced. He goes from, excuse me, he goes from being a 0 charge to a +2 charge. And manganese is reduced because he goes from a +4 charge to a +3 charge. And remember, you need to be able to identify what's being oxidized and what's being reduced. And that's it for tonight's notes. And as always, all the information on these Google Slides has been acquired and adapted from Pearson Chemistry's 2012 edition textbooks, resources CD, and pearsonchem.com. Thank you so much. Have a good night.